Welcome to PIDs and SEDS, Ways to Identify Things in Research. At the University of Guelph in Agri-food Data Canada, we are working on building the semantic engine. It's a suite of tools that will help researchers add meaning to their data. Now, in research, we often use identifiers, and it's important to be specific about what you are referencing. That's why we use an identifier. We can reference many things like a publication, a sample, a data set, and we often have adopted formal systems in science for consistent identification, like organism names that are very restricted, chemical names that are built by specific rules, societies that come up with objects for naming, etc. Now, as we move into the digital age, we're continuing to extend the use of identifiers. And globally, digitally, we want identifiers to be unique and global and persistent. So what we have done is we have created what we call in research PIDs, persistent identifiers. So examples of PIDs that you might have seen are DOIs, or digital object identifiers, ORCIDs, RORs, etc. So for example, when you upload a data set or another digital object to, say, the Agri-Environmental Research Data Repository at the University of Guelph, you will generate a persistent identifier, a DOI. So in this example here, you can see this is a screenshot from the repository, and the Agri-food Data Canada glossary has been uploaded. And highlighted there is the DOI. The DOI is the number, and then we can often stick it inside a URL. But the actual identifier is that number, letter, symbol combination. Now, the challenge with using these kinds of identifiers is that if you were to find the resource, like a data set, would you be able to go back and figure out what its identifier was? And if you did have that object, would you be able to tell if any of the data or content had been changed? So this is the concept that we are introducing about self-addressing identifiers. So self-addressing identifiers, or SEDS, are digital fingerprints of the file. And if you change the file in any way, then the fingerprint will change. And what we use to calculate the fingerprint is something, very common technique called a hash function. So a hash function is a one-way formula. And you put in your digital object, and you calculate the hash of that object, and at the very end of it, you can't take that hash and go backwards and calculate what the original input data was. So this means that hashing is really good for privacy because it means that people can't figure out just based on the hash what the original document was. So we have self-addressing identifiers that it is a hash of the document. So for an example, in Agri-food Data Canada for the semantic engine, we are helping researchers write digital schemas. The dataset schema is in the overlays capture architecture format, and all parts of the OCA schema and the schema bundle, everything all together, are all given SEDs. And the SED of each schema or overlay or bundle is the file name. So here we can see I've kind of blown apart one of the examples of an OCA schema, and we can see the different hashes that are identifying the different parts of this document. And the benefit of using a SED is that a digital object SED is the same no matter where the object is stored. So if you find two different objects and they have the same in two different locations, but they have the same SED, then you would know that the two objects are identical. And if you do find an object, like a schema, for example, that has no clear identifier, you can calculate the SED and then be able to use that to find how it's identified, like in the literature. So thank you very much from the University of Guelph at Agri-food Data Canada.